Look at question 2. The same tutor. Tutor 9.1, 9.2. Question 2. Okay, question 2 is the following table shows the enthalpy of formation of C5H12, CO2 and H2O. Okay, so you can see table given. The important thing you take note, the information given is about enthalpy of formation. Okay, I hope students remember the enthalpy of formation. Dia punya definition adalah heat change when 1 mole of compound is formed from its element at stated condition. Okay, so that is enthalpy of formation. Symbol dia adalah delta HF. And they give all the values for enthalpy of formation in kilojoule per mole for 3 different substances or compound. Okay, question A is they asked to find the heat of combustion. Okay, before that, I want to teach you to write the what we call the enthalpy of formation for all the 3 species. Kita kena belajar macam mana nak buat equation dia. Okay, first we look at enthalpy of formation untuk C5H12. Okay, we are going to write thermochemical equation for this one. Just a practice. So, carbon, solid, is the first element. The first element is carbon. The second element is hydrogen. So, hydrogen is hydrogen gas. Then produces C5H12. This is pentane, a liquid. Okay, so we get like this. And then this thermochemical equation, we write delta HF given is minus 173.2 kilojoule per mole. Okay, and then of course the equation is not balanced. Kita balance kan. So sini 5 carbon, sini 6 hydrogen. Okay, you get like this. This is formation of C5H12. Boleh dapat tak formation of C5H12? Saya ada buat dekat Jamboard. Nampak ke? Nampak Okay, itu yang pertama lah. Okay, yang kedua kita nak buat adalah enthalpy of formation untuk carbon dioxide, CO2 Okay, sama juga. Elemen pertama carbon, so carbon solid. Elemen kedua oxygen, O2 gas produces CO2 gas. Enthalpy of formation dia adalah sama dengan minus 393.5 kilojoule per mole. Okay, and then please take note here also the equation is already balanced. The equation already 1 carbon, O2, O2, so it's balanced. I want to remind you, this one is a reminder. Enthalpy of formation focus is 1 mole of compound, 1 mole of compound. Okay, but this one no need to write in thermochemical equation. Ini sebagai reminder lah daripada definition. Okay, alright. Next we go to the third one. The third one is enthalpy of formation of water. Enthalpy of formation of water. Okay, this is the third one, enthalpy of formation of water. So the first element is hydrogen. So we write here hydrogen gas. The second element is oxygen. Remember, it exists as O2 gas. And then we get H2O, which is a liquid. So this enthalpy of formation is minus 285.8 kilojoule per mole. Right? And please take note, this equation is not balanced. Okay, hydrogen H2, H2 balance. Sini 2 oxygen, sini 1 sahaja. Dan ini kita kena kekalkan dalam 1 mol. Maka you tak boleh darab 2 pada oxygen sini. You cannot multiply here with 2, cannot. Tak boleh sebab kita kekalkan dia dalam 1 mol. Maka yang ini kita akan jadikan half. Now we can see is 1 mole. Okay, so this is the enthalpy of formation of water. Okay guys, can you all get? Faham ke? Macam mana nak buat enthalpy of formation equation? Can, okay. So now we are going to learn a new formula. Today is the first time you're going to see the formula. The formula is enthalpy of combustion equals to summation of enthalpy of formation of products minus summation of enthalpy of formation of reactants. Okay. This is the new formula. I repeat again. Enthalpy of combustion equals to summation of enthalpy of formation of products minus summation of enthalpy of formation of reactants. Okay. So in this case, we have to know the products and the reactants. Okay. To know the products and reactants, we have to know the equation first. What I say is, we have to know the enthalpy of combustion of C5H12. Ini kena tahu dulu. What is the thermochemical equation? We have to know what is the thermochemical equation, which leads us to the question B. Okay. Membawa kita ke soalan B sebelum kita jawab soalan A lah. Okay. So we have to construct thermochemical equation for combustion of C5H12. First, to identify who are the products and who are the reactants in the thermochemical equation related to combustion. Okay. So we write the equation C5H12 liquid plus O2. Combustion mesti ada gas, must have gas, that is oxygen. And then we have CO2 gas and we have H2O liquid. And this is what we need to find, the question 1. So this is the thermochemical equation. We balance first. Kita cuba balancekan. So 5 carbon, here will be 5 carbon, sorry. Here will be 5. Hydrogen is 12, so here will be 6. And then 10, 16, so here 8. Okay. So now balance ready. Kita dah balancekan equation. We already balanced the equation. Okay. And now we can identify who are the products and who are the reactants. So this is our products and this is our reactants. Okay. And our reactant we will substitute here, and our product we will substitute here. Okay. So that we can utilize or use the formula. Okay. So now we go to calculation part. So enthalpy of combustion. Okay. Summation of product. Formation of summation of product. So we check our first product is CO2, but we have 5. Kita ada 5 CO2. You can check here, ada 5. Okay. CO2 punya nilai adalah minus 393.5 plus. Okay. And then we check water. That is 6. 6. So 6. Water punya value dalam jadual minus 285.8. This is summation of product. Okay. Maybe I use a red color pen to circle. This is called summation of product. Then we have to do the summation of reactant. Okay. Product dah habis, kita buat reactant lah. So saya padam ni. Ini just to tell you. Okay. Alright. And then minus. Now summation of formation of reactant. So reactant we have here we have 1 C5H12. So this bracket C5H12 is minus 173.2 multiply by 1 no need lah because it's same value. So plus oxygen is 8, oxygen 8. Okay, oksigen 8. And then perhatikan dalam jadual, the table enthalpy of formation of oxygen, they never give. Okay, here I want to include an important notes. Okay, maybe I go to slide number 14. Okay, enthalpy of formation of enthalpy of formation in elemental state is equals to 0 always. Contoh elemental state, hydrogen gas, this is 0. Oxygen gas, this is 0. Magnesium solid, 0. Chlorine gas, 0. In elemental state maksudnya macam mana mereka wujud lah. Dalam keadaan mereka wujud, iron solid contoh, kosong. So in elemental state, the enthalpy of formation is always 0. So you must know each compound, each element in the elemental state, how they exist. And in their most stable elemental state, the enthalpy of formation of that element is 0. Okay, so patah balik ke nombor 13. So now you see oxygen is in elemental state, O2. So it will be 8 multiplied with 0. Now we can calculate the enthalpy of combustion. Okay, kita kira sama-sama. Cuba tengok berapa anda dapat. Anyone? Berapa dapat Negative 509.1 kilojoule per mole. Don't forget the unit. Saya nak bagi tahu in thermochemistry, two things is very important. Two things you have to take note. Two things. Number one, phase. Number two, unit. Both are compulsory. Phase in the equation, unit in the calculation, and also equation. When you write thermochemical equation, the unit for the enthalpy is compulsory. Please take note. Sini ramai pelajar hilang markah lah. So I get Isiang got minus 3509.1 kilojoule. How about others? Dapat jawapan yang sama ke? Okay, so ini adalah jawapan. Okay, good. Ini adalah jawapan A. Heat of combustion kita dapat adalah minus 3509.1 kilojoule per mole. Okay. Moving into the B. B sebenarnya kita dah buat tadi. Saya akan tulis balik dekat slide number 14. Saya akan tulis balik. So C5H12 liquid, 8O2 gas, 5CO2 gas, 6H2O liquid, delta HC equals to minus 3509.1 kilojoule per mole. Okay, that is the thermochemical equation. Please take note, thermochemical equation written in one line. Satu baris. Jangan itu delta H turun ke bawah, salah. Thermochemical equation itu delta H mesti berada di hujung, one baris like that. Okay, boleh ke? Yeah. Okay, slide 15, soalan C. Okay, soalan C slide 15. Soalan 2C lah. Calculate the heat release if 15 gram of C5H12. So the info given is 15.0 gram of C5H12 is burned lah, combusted ataupun burn lah. Okay, So we want to know from our B calculation, sorry, not from B, sorry, from A. From A calculation, we find the enthalpy of combustion of C5H12 is minus 3509.1 kilojoule per mole. Okay, so a few things we have to take note here. Minus menunjukkan ini adalah combustion adalah satu exothermic lah. So negative here, not for the value. Negative is not for the value. Negative shows enthalpy of combustion is an exothermic reaction. Okay, and then here the second part is very important. Yang belakang ni. If you want to interpret the unit, we can interpret like this. 1 mole C5H12 release 3509.1 kilojoule per mole. Okay, ini adalah apa yang kita interpret daripada enthalpy of combustion. Okay, that is what we interpret from the enthalpy of combustion value. Enthalpy of combustion of C5H12 is equal to negative 3509.1 kilojoule per mole. Kalau kita interpret dalam stoichiometry kita, understanding kita, 1 mole C5H12 releases 3509.1 kilojoule per mole. Okay, 1 mole C5H12 bebaskan 3509.1 kilojoule. So kalau 15 gram, so maksudnya step pertama kita kena tahu berapa mole 15 gram ni lah. Kita kena tahu berapa mole. So macam biasa, mole equals to mass divided by molar mass. Mass is 15 gram. Molar mass of C5H12 is 72 gram per mole. So cancel the gram, kita kira mole. I get 0.208 mole. Dapat ke? Kita ambil sebab dia ni kan, sorry dia sebab 4 significant figure, so 283 because our enthalpy is 3509 it's already 4 significant figure, so kita ambil mole pun 0.2083. Okay guys, so far can follow?
Can, sir.
Okay, alright. So therefore we said, therefore 0.2083 mole C5H12 release minus 3509.1 multiplied by 0.2083, okay, times with 09.1, so I get minus 731.1 kilojoule. Dapat ke saya dapat nilai ni?